What if the key to everything, the real theory of everything, wasn't some exotic particle, but something we've been staring at all along? We're going to dive into a pretty wild idea today, that the biggest secrets of the universe are hiding in what we call empty space, the vacuum itself.
I mean, think about it. For almost a century, we've had this epic struggle, right? Trying to get our two best theories of the universe to just talk to each other.
And what if that entire struggle, all of it, was because of one single foundational mistake, an oversight about what reality is even made of? Okay, that's a huge claim, so let's get right into it. All right, so let's set the stage. The story really kicks off with this massive problem at the very heart of physics. You know, for the better part of 100 years, we've been working with this fundamentally broken picture of how the universe works.
So you've got these two titans, right? On one hand, you have general relativity. It sees the vacuum as this smooth geometric fabric, space-time. Then you have quantum mechanics, which sees the same vacuum as this buzzing, chaotic foam of virtual particles. They seem totally different. But here's the kicker. They both make the same mistake. They both treat the vacuum like it's just the stage, a passive backdrop for the real action, not as a physical, active player in the game.
And this really gets to the heart of it. The argument here is that the problem isn't the math. We've got brilliant mathematicians working on this stuff. The problem is ontological. It's about our basic assumptions of what is, what reality is actually made of. It's a what is it problem, not a how do we calculate it problem. Okay, so if the problem is that deep, the solution has to be just as profound. And that's where this idea, dynamic vacuum field theory, or DVFT for short, comes in. And it's all built on one single revolutionary idea. The core idea of DVFT is actually pretty simple to state. The vacuum is not empty. It's not nothing. In fact, it's the fundamental something. It's a real physical field. Think of it like an elastic medium that has properties you could actually measure, like density and stiffness. Now, this isn't just a rehash of the old ether concept. No, this is something much, much more dynamic. And here's why that's such a game changer. If the vacuum is the source of everything, then you don't have to try and cram all the forces together to unify them. Unification just happens. It's a natural consequence. Because gravity, light, matter, the whole shebang, it's all just different ripples, different behaviors of the exact same underlying stuff. So, okay, that sounds great in theory. But how does it actually work? How on earth could one single field produce things that seem so wildly different, like gravity and electromagnetism? Well, the theory says the vacuum has this key property called phase. And the ocean analogy is a really good one. Picture this massive cosmic ocean. When there's a huge, slow, smooth swell that curves the whole surface, that's what we feel as gravity. But what happens when a wave gets really sharp and actually breaks? It creates this complex, twisted chaos on the surface, a topological defect. And that, according to DVFT, is what we see as light and electromagnetism. You can see the comparison laid out pretty clearly here. Gravity, that's the smooth, predictable, kind of Gaussian behavior of the vacuum. Electromagnetism, that's the sharp, messy, non-Gaussian stuff. They look like total opposites, but they're not. They're just two sides of the same coin. Two different ways the exact same field can behave. And that's the real beauty of it, isn't it? No need for extra dimensions or a whole zoo of new particles. It's just one vacuum with two distinct modes of behavior. Pretty elegant.
All right, but unifying forces is one thing. A really powerful theory has to do more. It needs to explain the stuff that's been bugging us for ages. And there's hardly a bigger puzzle out there than Einstein's equivalence principle.
So we've known for over 100 years that an object's inertial mass, its resistance to being pushed, is exactly the same as its gravitational mass, how much it's pulled by gravity. We know they're the same, but we've had no clue why. It's just been a fact we accept and build on. Well, DVFT says, hold on, there's a physical reason for this.
And it requires a total shift in how you think about it. Inertia? That's not some intrinsic property of the object. It's the physical vacuum itself pushing back when you try to accelerate something through it. And gravity? It's not some mysterious force reaching out and pulling things. It's just an object following the path of least resistance along a curve, a gradient that's already there in the vacuum.
And this is the real aha moment. From the vacuum's perspective, it can't tell the difference. Whether an object is being shoved through it by a rocket or whether it's just falling along a curve in the vacuum's own structure, to the vacuum, it's the exact same kind of deformation,
So its reaction, the thing we measure as mass, has to be identical. It's not a coincidence, it's a necessity.
So just like that, the equivalence principle stops being this weird, mysterious coincidence. It's an unavoidable consequence of having a physical vacuum in the first place. It's not something you have to assume, it just emerges naturally from the physics. But look, explaining things we already know is great, but it's not enough to be good science. A real theory has to stick its neck out. It has to make new predictions that we can actually go out and test. It needs to tell us, hey, look, over here, this is where your old theories are going to break down. And because DVFT explains the equivalence principle as a result of the vacuum behaving in a pretty simple way, it also tells us exactly where that principle should start to get a little weird. It should start to break down in extreme situations where the vacuum is really stressed out, nonlinear, or full of those defects we talked about. And we're not talking about vague philosophical ideas here. These are hard, concrete, testable predictions. The theory says we should be able to measure tiny violations of this principle near something like a black hole, or that maybe an object's mass could change ever so slightly depending on its acceleration history. Or maybe, just maybe, different materials fall at very slightly different rates. Every single one of these is a specific signal we can hunt for, a signature that would tell us our current picture of the universe is missing something big.
And that right there is the most important step any theory can take. It crosses the line from being a neat idea, just philosophy, into being real, testable science. It's making a bet. And that's exactly what a good scientific theory is supposed to do.
So let's just pull this all together for a second. This huge puzzle of unification, this deep mystery of the equivalence principle, it feels like it all comes back to that one foundational mistake we made at the very beginning.
And at the end of the day, here's the diagnosis. The reason we couldn't get gravity and quantum mechanics to play nice is because we thought the vacuum was just the playing field. The moment you realize the vacuum isn't the field, it's the most important player on the field, well, that's when unification stops being a problem and starts looking like an inevitability. The vacuum itself is the source. Which leaves us with one last kind of mind-bending question. Is it possible that for the last 100 years, we've been trying to understand the show while completely ignoring the stage, the actors, and the script? Could the secret to absolutely everything have been hiding all this time in what we dismissed as nothing?